Hello out there to you. In this video, I'm going to solve for profit maximizing quantity and price for a monopoly. This problem calls it a pure monopoly. And we're just going to do that by hand in this one. Okay, so you can do that on some kind of test. We've been given price and quantity. So looking at this is a demand schedule right here. As the price falls, the quantity increases. And if you were to graph this, this would be your downward sloping demand curve right there. Okay, we're not going to graph it, we're just going to use the table. Total revenue is the amount of money in the cash register, so it's price times quantity. Marginal revenue is the change in total revenue divided by the change in quantity. Now, in this particular problem, we're increasing the quantity by 1 every time, so the denominator in that problem is going to be 1. Okay. Total cost we're given, and then marginal cost is the change in, I had that right, total cost divided by the change in quantity. Okay, so when we want the profit maximizing condition, this is going to be your microeconomics tattoo. We need to produce up to the quantity where marginal revenue equals marginal cost. So that's what we're looking for. The steps are we're going to calculate both of those, find the quantity where that happens, and then we want to mark up the price. Okay, so find the corresponding price that corresponds to that particular quantity. Okay, so let's start filling in the table. This is 0, this is 41, this is 76. What I'm going to do now is pause the video and fill in the rest of those so you're not just watching me do arithmetic. Okay, and through the magic of the video, should have filled in the rest of those. Okay, so now let's do marginal revenue. Let's pick a different color here. So the additional revenue right here is 41. Some people find it easier to take this number and subtract the previous number. That is fine. I like to think about what do I have to add to this to get to here. Either way, you'll get the right answer there. So that's going to be 35. That's going to be 29. Okay, and notice these are below our demand curve. Okay, that is 17, I believe. Yeah, 11, 5. Now we go to -1 and -8 and -13. Okay, so marginal revenue goes negative, and that's consistent with what you might see on a graph. Now we want to do marginal cost. We'll do that in red. So it's the additional cost, or this minus this, which is 12, 10, 5, 1, 2, 3. Okay, and now I can find this profit maximizing condition if I just compare where I'm at. So the answer immediately jumps out because 5 equals 5 right here. Sometimes, no, that's not what I wanted to say. So what you could do is you could go line by line. You could say marginal revenue will make $41 on the first unit. It cost us 12. We're going to go ahead and produce it. You could go line by line as long as marginal revenue is higher than marginal cost. I'm going to produce it, and we're going to produce it right up till it equals, right? So that's the equaling, and then we're not going to produce down here. We don't want to produce those 8 units. Okay, so like the whole reason you should care about this is, you know, if you never took an economics class, you'd be like, well, I can produce 10 units. Let's go ahead and rock and roll, produce 10 units. But that's not the right answer. Last step is I want to know what price to charge. So the quantity is going to be 7. What's the most consumers are willing to pay for those 7 units? And it's 23, because that's their spot on the demand curve. Okay, now if I wanted to know what the profit in total was, This is going to be 161. So profit is total revenue minus total cost. Looks a little weird. So 161 minus 98, which is 63. So profit in this case is 63. You just fill that in. And if you wanted to, I mean, you could sit here and go line by line and see if that's the highest profit. But we know it is because of doing the profit maximizing math that we did.